Good morning, sir. My name is Saidaja from Triple Department. Subject Process Control and Instrumentation. Subject code AEED62. Assignment topic Open Loop versus Closed Loop System. Open loop versus closed loop control system. A comparative study of automation architecture. Control system overview. Control system manages, command, direct or regulate the behavior of other systems or devices. They are vital in automation, robotics and industrial processes. Open loop control operates without feedback. The output has no influence on the control action. The simplicity and low cost are key benefits. Closed loop control system incorporative feedback from the output to input, ensuring automatic error correction for greater accuracy and stability. Why compare both? Understanding both systems allows engineers to balance efficiency, cost, and precision in decision design and implementation. These three are the a comparative study on automation architecture. Introduction to control system. Foundation of automated decision making. Definition: a control system is a configuration of physical component designed to regulate the behavior of other devices or systems by manipulating input to achieve desired output. Purpose: its main function is to maintain process variables like temperature, pressure, or speed within a specified range despite external disturbances. Historical evolution. From mechanical governors in steam engines to digital PID controls, control systems have evolved to enable precise automation across industries. Significance in modern engineering. They form the backbone of industrial automation, robotics, aerospace, and smart infrastructure, ensuring efficiency and reliability and consistency. Basic components of a control system. Element defining system structures and functionality. Controllers, actuators, process of plant, sensors and feedback. Controller, the decision making unit that determines the control signal based on the desired set point and the measured feedback. Implement local algorithms like PID or state feedback. Actuators convert electrical control signal into a physical action like motor, valves or hydraulic system that manipulates the process or plant. The physical system being controlled, represented mathematically by a transfer function g of s that defines input output dynamics. Sensors and feedback path measures the output and sends it back to the controller for comparison, enabling dynamic correction through feedback signals h of s. Open loop system overview. Unidirectional control without feedback. Definition, block diagram representation, characteristic, example statement. Definition: an open loop system acts slowly on the basis of input commands without using feedback from the output to influences its action. Block diagram representation composed of an input signal, controller, actuator, and process mathematically represented as the output is equals to g of x in g of s into input. Characteristics: simple, low cost, and inherently stable since feedback is absent. However, it cannot compensate for disturbances or parameter variation. Exam exam include electrical washing machine, toasters, and open loop motor drives where the control action does not depend on the actual result. Examples of open loop system illustrating directional control in everyday and industrial contexts. Washing machine operates on a preset timer, does not adjust washing duration based on cleanness level or load level. Fixed time open loop control. Electric toaster heat for a defined period regardless of bread color or type. No sensor. Feedback governs heating termination. Electric kettle without thermostat. Heat until manually turned off or timed. Lack temperature feedback to ceases operation automatically. Conveyor belt system moves material at a constant speed set by the operator. No feedback ensure position and accuracy. These four are the example for the open loop control system, illustrating unidirectional control in everyday and industrial context. Advantages and limitations of open loop system. Evaluating simplicity against controlled precision. Advantages: simplicity and low cost. Advanced stability and predictability. Limitations: inaccuracy and disturbances sensitivity. Limitation: no self correction. Advanced simplicity and low cost. Open loop systems are easier to design, implement and maintain as they lack feedback mechanism. Their hardware and composition requires are minimal. Advantages: stability and predictability. Because there is no feedback, the system dynamics are predictable and free from the oscillatories or feedback include instability. Limitation: inaccuracy and disturbance sensitivity. Open loop system cannot compensate for changes in load parameters, variations, or environmental disturbances, resulting in poor precision. Limitations: no self-corrections. Lack of feedback prevents error correction. Output deviation accumulate over time, reducing reliability in critical control scenarios. These are the advantages and limitations of open loop system. Closed loop system overview. Dynamic feedbacks for precision and stability. Definition: a closed loop system utilizes feedback from the output to influences control action, automatically adjusting for the disturbances and errors. Functional representation expressed mathematical as the output g of s by 1 plus g of s into h of s into input, where h of s represents the feedback path transfer function. Characteristics: adaptive, accurate, and capable of self-correction. Provides steady-state errors minimization, improved transient performance. Example system. Example include thermostat, cruise control system, automatic voltage regulators, and robotic servo mechanism. This is the closed loop system overview. Dynamic feedback for precision and stability. Example of closed loop system: feedback driven controls in practice. Thermostat controlled heating system, cruise control in automobiles, automatic voltage regulator (AVR), robotic servo mechanics. Thermostat controlled heating system monitors room temperature and adjusts heating output automatically to maintain the set point. Feedback ensures thermal stability. Crucial controls in automobiles measures vehicle speed and adjusts the throttle to maintain a target velocity, compensating for and or load variation. Automatic voltage regulator (AVR) maintain constant generator output voltage by adjusting excitation current based on feedback of voltage deviation. Robotic servo mechanics employs sensors to continuously correct joint position and velocities, achieving high precision motion control. Advantages and limitations of closed loop system: balancing accuracy and complexity. Feedback advantages: high accuracy and adaptability. Feedback enables automatic error correction, ensuring precise control even under load variation and external disturbances. Advantages: improved stability and performance. Closed loop system achieves better transient and steady state response, reducing overshoot, rise time, and steady state errors. Limitations: increased complexity and cost. Requires additional sensors, feedback path, and controllers, leading to higher implementation cost and maintaining challenges. Potential for instability. Improper feedback gain or phase lag can cause oscillations or instability, mitigating ranges, designs, and tuning. Comparative analysis: open loop versus closed loop system. Contracting control characteristics and performance. Feedback mechanism: open loop systems lacks feedback, relying solely on input commands. Closed loop system incorporate feedback for continuous correction. Accuracy and stability: closed loop system achieves higher precision and disturbance rejection, whereas open loop system exhibit fixed non-adaptive response. Complexity and cost. Open loop architecture are simple and economical, while closed loop and design mathematical behavior. Applications in industries. Conclusion: the evolution of control system in era of intelligence, the series of key insights, emergence of adaptive and intelligent control integrated with IoT and cyber physical system outlook for engineers. Thank you.